graphing functions. So a function, again, is a type of relation. A function, each input has only one output, and we can write functions in a plethora of different ways: graphs, tables, equations, mapping diagrams. We're going to be taking a look at our equations for the moment and seeing how we can graph that. So this is going right back to what we did in chapter 4, graphing and equations. So looking at equation, coming up with a table, graphing those ordered pairs so that we can see the pattern, and drawing the line to show all of the ordered pairs that fit that equation. So we're going to graph the function y equals negative 2x plus 1, and we're going to use the inputs of negative 1, 0, 1, and 2. So we're telling you what we're going to use for x here. So these are the same steps that we've used in the past to graph from an equation. We're going to make a table, and then we're going to plot the ordered pairs and draw a line through the points. So same old here. Make ourselves a table. Again, I want to see you do the work, please. Again, we want to make sure we're being exact and precise with our numbers here. Please don't try to flip it all through your head. Write it out for at least the first few so that you can see the pattern. So here I took my negative 1 as my input, I plugged it in, and I got 3 as my output, so that's my y value. I plugged in 0 and came up with 1 as my output, so that's my y value. 0, 1 is one of my ordered pairs. I plugged in 1 into my equation, and I came up with negative 1 as my output, so 1, negative 1. I started to see the pattern then, that it was going down by 2's every time, so I filled in the rest of the table from there. So now I have 4 ordered pairs. I went over to my coordinate plane, I graphed those 4 ordered pairs. They definitely are a function. Remember, for a function, each input has only one output, so that's definitely true. And then I drew a line through that pattern because they did make a straight line there. Not all functions make a straight line. They don't have to. We've seen that before. But these do make a straight line, so it was pretty easy to draw what the pattern looked like. So remember, they're asking you to graph the function. They're not asking you to graph only these ordered pairs. They want to see all of the ordered pairs that make this one true. There's an infinite amount of ordered pairs that make this equation true, so I need to draw the line to show all of them. Alright, let's take a look at another one in a word problem form. Remember, we said we can work from equations, we can work from words. The distance m in miles traveled by a car is 35 times the number of gallons, g, of gasoline used by the car. So I can figure out my miles if I know what the gallons are. So my miles is going to be my output, my gallons are going to be my input. Write and graph a function that describes the relationship between m and g. So I know that if I know how many gallons I have of gas in my car, I can figure out how many miles I can go. So again, my miles is my output, my gallons is my input. So my miles is 35 times the number of gallons. So the miles is 35 times the number of gallons. I have an equation at this point, so I'm going to go back to what I know how to do to graph this. I'm going to make up a table and then set up my coordinate plane. Since we have gallons of gasoline here, it makes sense to use positive values. I'm never going to have a negative number of gallons of gasoline. I could also have used 0. If my 0 is my input, 0 is my output. Going back to good old chapter 4, that is a proportional relationship because it has a constant rate of change and it goes to the origin at 0, 0, no gas, no miles. So here's what I came up with for my table so that I could see my pattern. Since I knew I was going up into the 100s, I set up my coordinate plane here so I could get up to the 100s, but I counted by ones on my x-axis here because these are pretty small numbers. So when it's real world, feel free to set up your axes with different intervals so that you can fit the points that you need to. So I graphed my points here. I know it goes through the origin because, again, no gas, no miles. And then I drew a line here because I could have, I've changed my things here. This should be gallons, and this should be miles. I hope you got that. I hope you fixed that, and I hope you noticed that. So here's my gallons here. So I know that if I have this number of gallons, I have this number of miles that my car can go. But I could have half a gallon, I could have 3.5 gallons. That would give me a certain distance of miles that my car could go. So it makes sense to draw a line for these because I could use those numbers that are in the middle. So using a function rule and making a graph by using a table, or writing a function rule from a word problem and then being able to set up a graph from that to see the pattern.